Your teacher today is Dr. Bbosa Science. Dr. Bbosa is a teacher at the Science Foundation College, the best school that teaches sciences. Today we are going to study Organic Chemistry, Lesson 11. Chemical properties of alkyl halides. A. Formation of alkenes from alkyl halides. Alkyl halides react with hot alcoholic potassium hydroxide to form alkenes. The mechanism depends on the class of alkyl halides, but the mechanism for secondary alkyl halide is either that of primary or tertiary alkyl halides. Primary alkyl halides, for example, chloroethane reacts with hot alcoholic potassium hydroxide to form ethene. In the mechanism, ethanol reacts with potassium hydroxide to form potassium ethoxide and water. Then the ethoxide ion removes a hydrogen atom from the carbon next to the one carrying a chlorine atom. A double bond forms as the bond between that carbon atom and chlorine atom breaks to form ethene. Example 2. 1-bromopropane reacts with hot alcoholic potassium hydroxide to form propene. In the mechanism, ethanol reacts with hydroxide ion to form ethoxide ion. Then ethoxide ion removes a hydrogen atom from carbon atom 2 next to the one carrying the bromine atom. A double bond forms as the bond between that carbon atom and bromine breaks to form propene. Exercise. Complete and write a mechanism. 1. Between 1-chloro, 2-phenyl ethane and hot potassium ethoxide in ethanol. You can pause and answer. Solution. 1-chloro, 2-phenyl ethane reacts with potassium ethoxide in ethanol to form phenyl ethene. In the mechanism, the ethoxide ion removes hydrogen atom from a carbon atom next to the one carrying a chlorine atom. A double bond forms as the bond between the carbon atom and the chlorine atom breaks to form phenyl ethene. 2. Tertiary alkyl halide undergo elimination unimolecular E1. Unimolecular is the molecularity of the reaction, as we shall see. Chemical kinetics in physical chemistry. For example, 2-iodo 2-methylpropane react with a solution of potassium methoxide in methanol to form 2-methylpropene. In the mechanism, 2-iodo 2-methylpropane ionizes and forms a positive charge on carbon atom that originally carrying the iodine atom. The methoxide ion then removes a hydrogen atom from a carbon atom next to the one carrying a positive charge. A double bond forms to form 2-methyl propene. Exercise: complete and write a mechanism. Roman 1. Between 2-chloro, 2-phenylpropane and hot potassium oxide in ethanol. You can pause and answer. Solution: 2-chloro, 2-phenylpropane reacts with hot potassium oxide in ethanol to form 2-phenylpropene. In the mechanism, 2-chloro, 2-phenylpropane ionizes to form a positive charge on the carbon atom originally carrying a chlorine atom. Then a oxide ion removes a hydrogen atom from a carbon atom next to the one carrying a positive charge. A double bond forms to form 2-phenylpropene. B. Reaction of alkyl halides with alkalis. Alkyl halides react with hot alkalis to form alcohols. Secondary alkyl halides react by either mechanism of primary or tertiary alkyl halides. Primary alkyl halides, for example, chloroethane, react with hot potassium hydroxide to form ether. In the mechanism, the hydroxide ion donates a pair of electrons and bonds with a carbon atom carrying a chlorine atom. Concurrently, the bond between that carbon atom and chlorine atom breaks to form ether. The mechanism is described as SN2 substitution nucleophilic bimolecular, because the nucleophile hydroxide ion substitutes a halogen atom and the slow step involves two species: the bonding of the hydroxide ion or a nucleophile and the breaking of the bond between the carbon and the halide atom. 2. Tertiary alkyl halides. For example, 2-bromo, 2-methylpropane react with hot potassium hydroxide to form 2-methylpropane 2-ol. In the mechanism, 2-bromo, 2-methylpropane ionizes and a positive charge forms on a carbon atom originally carrying a bromine atom. The hydroxide ion then donates a pair of electrons and bonds with the positively charged carbon atom to form 2-methylpropane 2-ol. The mechanism is described as SN1 because a nucleophile substitutes a halogen atom and the slow step involves only one species, i.e. the ionization of the alkyl halide. Exercise: complete and write a mechanism. 1. Between chloro, phenyl, methane and sodium hydroxide. You can pause and answer. Solution: chlorophenyl methane reacts with sodium hydroxide to form phenyl method. The mechanism is as follows. Note that chlorophenylmethane is a primary alkyl halide. Between 2-iodo-2-phenylpropane and potassium hydroxide. You can pause and answer. Solution. 2-iodo-2-phenylpropane react with potassium hydroxide to form 2-phenylpropan-2-ol. The mechanism is as follows. You can pause and write. Note that 2-iodo-2-phenylpropane is a tertiary alkyl halide. Reaction with potassium cyanide. Alkyl halides react with potassium cyanide to form nitriles. The reaction is important because it increases the carbon chain by one carbon atom. Primary alkyl halides undergo SN2 substitution nucleophilic biomolecular, while tertiary alkyl halides undergo SN1 mechanism substitution nucleophilic unimolecular, whereas secondary alkyl halides undergo either mechanism. Primary alkyl halides. For example, chloroethane reacts with potassium cyanide to form propane nitrile. In the mechanism, the cyanide ion donates a pair of electrons and bonds with the carbon atom carrying a chloride ion. As the bond between that carbon atom and the chlorine atom breaks to form propane nitrile. 2-bromo-2-methyl-propane react with potassium cyanide to form 2,2-dimethyl-propane nitrile. In the mechanism, 2-bromo-2-methyl-propane ionizes to form a positive charge on a carbon atom, originally carrying the bromine atom. The cyanide ion then donates a pair of electrons to the positively charged carbon atom to form 2,2-dimethyl-propane nitrile. D. Coupling reaction. 2 alkyl halides couple in the presence of sodium and dry ether, or zinc and copper couple to form alkanes, twice the number of carbon atoms as the parent alkyl halide. For example, chloroethane couples in the presence of sodium and dry ether to form butane. 1-bromopropane couples in the presence of sodium and dry ether to form hexane. E. Formation of Grignard reagents. Alkyl halides react with magnesium in presence of dry ether to form compounds called Grignard reagents. For example, chloroethane reacts with magnesium in presence of dry ether to form ethyl magnesium chloride. Generally, alkyl halides react with magnesium in presence of dry ether to form alkyl magnesium halide, which is a Grignard reagent. Grignard's reagents are important synthetic molecules because they increase the parent carbon chain by unlimited number of carbon atoms in the synthesis. 1. Grignard reagents react with carbon dioxide to form carboxylic acid. Here, the parent chain increases by one carbon atom. That is, alkyl magnesium halides plus carbon dioxide in dry ether form a compound that hydrolyzes to form a carboxylic acid. For example, ethyl magnesium chloride react with carbon dioxide in dry ether to form a compound which hydrolyzes in the presence of a dilute acid to form propanoic acid. 2. Grignard's reagents react with methanol to produce primary alcohol. Here, the parent chain increases by one carbon atom. That is, alkyl magnesium halide react with methanol to form a compound that hydrolyzes to form a primary alcohol. For example, methyl magnesium bromide reacts with methanol in the presence of dry ether to form a compound that hydrolyzes to form ethanol. 3. Grignard's reagent react with aldehydes to produce secondary alcohols. Alkyl magnesium bromide react with an aldehyde in the presence of dry ether to form a compound that hydrolyzes in dilute acid to form a secondary alcohol. For example, methyl magnesium bromide react with propanol in dry ether to form a compound that hydrolyzes to form butane 2-ol. 4. Grignard's reagents react with ketones to form tertiary alcohol. Alkyl magnesium bromide reacts with a ketone in the presence of dry ether to form a compound that hydrolyzes in dilute acids to form a tertiary alcohol. For example, methyl magnesium bromide reacts with butanone to form a compound that hydrolyzes in dilute acid to form 2-methyl butane 2